So now we're going to talk about what security actually is. So this is the outline of the talk. We'll talk first about security versus reliability, which is a big contrast in the way you have to think. And then we're going to talk about the security policy, which is basically how we set up our goals and how we actually define what we want to achieve in our security. And then we have different protection strategies, because obviously you can do more or you can do less, and sometimes less is perfectly fine. And finally, we're going to talk a bit about the security objectives, which is different types of things that we actually want to achieve. So different categories of what we want to achieve. So first, reliability. Reliability addresses the consequences of unintentional errors. So for instance, if you have a PC which is offline, then you are in control of the software components and you are in control of all the input that these software components send to each other. So the aim here is to avoid mistakes, because usually you don't attack yourself on your computer system. You don't try to ruin things for yourself. So there is no point in trying to prevent such malicious input. So the idea here is for reliability is to avoid common mistakes that can cause problems. Security, on the other hand, that's basically when you put this system online and then you have hostile adversaries that can provide input. So protection against common mistakes is not enough, because this adversary will ensure to make those mistakes for you, and hopefully from his perspective he can abuse them to actually achieve things in your system that was not intention. So basically they will also do a lot of stuff that you would never ever accomplish by mistakes. So they are very much outside what you would usually test as common mistakes, like typos and stuff. So they would so if in reliability you check for typos, then so like entering characters instead of numbers, or the other way around, then in the security perspective, the adversary, he would try to input characters that you cannot even type on a keyboard. So you would never catch that by testing for reliability. So basically, to make software more reliable, it is tested against typical usage patterns. So software testing is perfectly fine from a reliability point of view. However, to make software more secure, you have to test it against non-typical usage patterns. And that's basically everything. So all possible input, and that's a rather large input space, which is very difficult to actually test, because it will take quite some time to test everything. So here you basically have to think before you do things to be secure. So the main purpose of security, that's to protect assets. So we define our goals in a security policy. So for instance, who may access what asset and how, and then we have to enforce this policy, and there are various mechanisms we can use to achieve that. So for instance, we have an asset which is private photos, and then our policy is only I can access my photo collection. I can share individual photos to individual persons. And then the question is, how do we enforce this? Usually, people store their photos well, nowadays in the cloud, where they say that, okay, I want to share, be able to view my photo collection except with whom I share particular photos. And then this system will basically controls all your photos, and then they will see who tries to access it and check who that person is and allow that person to view it if it's you, or if it's one of the persons with whom you've shared this particular photo they are requesting. And each of these mechanisms that we use is more or less trustworthy. So the definition of trustworthy here is that a trustworthy mechanism will not break our security policy because it's perfect. So it will not break the security policy. However, a trusted mechanism, that is a mechanism that you trust to not break, but it doesn't say anything about whether it will break or not break your security policy. So for instance, most people trust the cloud to keep their photos safe, but that doesn't mean that the cloud actually will keep them safe. There are attacks against, well, data breaches every now and then, where someone has gotten access to data from a cloud which they were not supposed to be able to get it from. So the cloud is not necessarily trustworthy, but it is trusted by a lot of people. So protection strategies, we can have different protection strategies to prevent this from happening. So or not necessarily prevent, but prevention is the first protection strategy. So taking measures that we prevent our assets from being damaged. So for instance, we wouldn't upload our photos to a cloud, but we would print them on paper and put them in a thick locker in the basement, which is fire protected. So even if there is a fire, they will not get lost. So then they are safe. We take measures to prevent anything from happening to them. The second is detection, which means that you take measures to detect when and how and possibly by whom an asset has been accessed or damaged. And the final one is reaction. So taking measures that allow us to recover the assets or recover from damage to the assets. So for instance, private property is a good example. So we have prevention, which means we have locks on doors, window bars and surrounding walls. And detection would mean that we see that items are missing, or we have burglar alarms or video surveillance. And the reaction part is, of course, that we call the police and possibly replace the stolen items, possibly by insurance. And finally, another example, private photos, and we get back to that one. So the prevention would be to encrypt them and store them securely and have the key on our person and never store it anywhere so anyone can get hold of it. And detection is, of course, that our photos have leaked to the web. So we see our photos on the web and then we realize, oops, someone has leaked our photos. And the reaction in this case, I suppose, is get angry. There's not that much to do if your photos leak to the web. So there are some legal actions you can possibly take, but probably you cannot get rid of this. So the security objectives that we want to achieve, usually they are divided into three general categories. So the first one is confidentiality, which concerns unauthorized disclosure of information. The second one is integrity, which concerns unauthorized modification. And finally, availability, which concerns unauthorized withholding of information or resources. So in this case, we make a distinction between data and information. So we have this quote: data is the physical phenomena chosen by convention to represent certain aspects of our conceptual and real world. So the meanings we assign to data are called information. And so data is used to transmit and store information and to derive new information by manipulating the data according to formal rules. So basically, data is what we store, and information is the meaning of that data. So our photos is data, and the things they depict, that's the information. To give just one example. So another example is x plus 1 equals 0 implies that x is minus 1. So the two equations are data, and in this example we've used the formal rules of linear equations to derive the value of x. So if we have the first equation, x plus 1 equals 0, we can figure out what x is. And another example is timestamps of TCP packets on the network. So with the port set to either 80 or 443. So these are the two ones used for the HTTP protocol usually. And then we can apply the formal rules of statistical analysis. So for instance, although the information here is simply a connection from one computer to another, if we actually analyze this and look at, for instance, timestamps and things like that, we can actually infer things. So for instance, if it's in the middle of the night and we have these packets coming over the network, that implies that someone is not sleeping. Well, it depends on the type of traffic, but you can infer things like that. So then the data is simply timestamps on TCP packets, and the information is actually that someone is awake and not asleep. So back to the objective. So confidentiality, as we said, that's basically unauthorized reading, and reading in the very general sense. It implies hearing and seeing and whatnot. So one important thing about confidentiality is to think about what it is that is confidential and what we want to hide. For instance, do we want to hide the content of a document, or do we want to hide even the document's existence? Because those are two different things, because the existence of a document might imply something. So if a document exists, even if we can't read it, that's data, and we might actually be able to infer information about that, which perhaps we shouldn't. Like, for instance, the title of a document might reveal a lot, although its contents is not visible. And integrity is the corresponding unauthorized writing, and writing in the very general sense. So data integrity has various definitions. And so one is that the state that exists when computerized data is the same as that in the source document and has not been exposed to accidental or malicious alteration or destruction. So that's one definition of data integrity. And basically it concerns detection and correction of intentional and unintentional modifications of data. It can also be permitted to modify data in such a way that assets or accounting records of the company are lost or corrupted. That is basically making sure that everything is as it's supposed to. So integrity is in this form is quite difficult to achieve. But integrity in general, I mean, if we take the general sense of integrity, is usually a prerequisite for many other services. So if we want to do stuff, we usually require integrity in most cases. So the last one is availability. So this is the property of being available and usable upon demand by an authorized principal. So basically, the big class of attacks against availability is denial of service. And this basically prevents authorized access to resources, specifically network resources. It's commonly used, but it's the same same term in general. A common denial of service attack is distributed denial of service attacks. And basically, this could be a reliability issue as well. Because, for instance, if a web server has too slow connection to the internet and a lot of people want to use the service at once, then it gets so much traffic, so its connection is congested, which means that people who want to use the service might actually not be able to because it's way too slow to communicate. So this has happened numerous times by accident. Nowadays, it's usually not a reliability problem anymore. Most organizations have come to terms with that, so they can handle it. But still, there are times of malicious actors when they deliberately send a lot of requests to a single service to make it unavailable. So, for instance, a lot of insecure Internet of Things devices can easily be used for this. So, for instance, if attackers infect a few 100,000 or millions of IoT devices, smartphones or home routers and whatnot control, and then when an attacker basically controls millions of devices, he can instruct all of them to send requests to a given server or computer on the internet at once. And with such a load, this device is simply overloaded, so no real user of that service can communicate with it during this time. So there are various attacks where people have held services to ransom. So they have do one of these distributed denial of service attacks and ask the company or organization to pay ransom and to make them stop. So that was everything about what security is all about.